Hello everyone and welcome back. So today we are going to solve this question. What estimate does the trapezoidal rule with two subdivisions give us for the integral of sin x dx from 0 to pi by 2? So we can use our root 2 as 1.4. Alright. So what do they mean by trapezoidal rule? So what they mean by trapezoidal rule is, so right here I have the graph of y equal to sin x and we have to integrate it from 0 to pi by 2. So two subdivisions, right? So we need to so this is from 0 to pi by 2. So the midpoint is going to be pi by 4. So at around pi by 4 is around 0.7675 something. So I'll make it somewhere here. We are going to divide it into two shapes, and let's just connect the origin to this and this to this. So what we have to do with the trapezoidal rule is calculate this area separately using our general geometry and then add them up, and now they are asking us to see how accurate this integral is compared to the regular integration. So let us see what we can do. So let us name these points. I'll name my origin as O and this point as A, B and C, D. Yeah, so I'd say integral of sin x dx from 0 to pi by 2 will be area of triangle AOD plus area of ABCD, trapezium ABCD. Alright, now let us label some things. What is the value of D going to be? I'll just mark this as pi by 4. So the value of D is going to be sin pi by 4, which is 1 by root 2. So AD is equal to 1 by root 2. AD equal to 1 by root 2. What is OA? OA is equal to pi by 4, that is obvious. And what will AB be equal to? So AB will be equal to pi by 2 minus pi by 4, which is also pi by 4. AB equal to pi by 4. And what is CD equal to? We know that C will correspond to sine of pi by 2. So CD is going to, which is 1, sin pi by 2 is 1, so CD is going to be 1. So now we have all the required lengths which we can use to calculate the area. So let us find the area of triangle AOD. Alright, so this is going to be half the times base which is OA into height which is AD, and which is half AD. OA is pi by 4 and AD is 1 by root 2. So we get pi by 8 root 2. Alright, that's done for triangle AOD. Now we need to find it for quadrilateral ABCD. We have this A, B, C, D. This length is 1 by root 2 and this length is going to be 1 and this distance is pi by 4. So as AD and BC are perpendicular to the x-axis, we can say that AD is parallel to BC. Therefore we can say that ABCD is a trapezium. Yeah. So what is the area of a trapezium? So area of a trapezium, area of ABCD, a trapezium, is given by half into height into sum of parallel sides. Alright, now we just need to find those. What is the height here? So these two are the parallel sides, so height is going to be the distance between the parallel sides, which is pi by 4, which is AB. 1 by 2 times AB. And what are the parallel sides? AD and BC times AD plus BC. Alright, now let's just plug in the values. So we get 1 by 2, AB is pi by 4 times AD plus BC, which is 1 plus 1 by root 2. Alright, let us just simplify this. So pi by 8 times root 2 plus 1 by root 2. I just took an LCM and added up the fractions. So we get pi by 8 root 2 into root 2 plus 1. Okay, this is the area of the trapezium. So what will the total area be? Total area is area of triangle AOD plus area of ABCD. So let's go back and see what's the area of AOD. That's pi by 8 root 2. So this is pi by 8 root 2, and this is area of ABCD is pi by 8 root 2 times root 2 plus 1. Okay, plus pi by 8 root 2 times root 2 plus 1. Let us take pi by 8 root 2 common. Pi by 8 root 2 times 1 plus root 2 plus 1, which is pi by 8 root 2 times 2 plus root 2. Now let us factor out root 2 from the numerator, so which is pi root 2 times root 2 plus 1 by 8 root 2. So we are finally left with pi by 8 times root 2 plus 1. Now let us use a calculator to evaluate this. Let us take root 2 as 1.4 and pi as 3.14. So here's our calculator. So we have pi by 8 into root 2 plus 1. Let us evaluate the root 2 plus 1 first. So root 2 is 1.4, root 2 plus 1, which is 2.4, into pi by 8 into pi, which is 3.14, divided by 8. So we are left with 0.942. So this area is approximately 0.942 square units. Okay, now let us take one step ahead and actually compare, and let us see how accurate this is. So now let us do the integral of sin x dx from 0 to pi by 2. Sin x dx from 0 to pi by 2. So what is the integral of sin x? That is minus cos x. Minus cos x from 0 to pi by 2. Let's put in the limits. So which is, this can be, okay, let's just do it. Minus cos pi by 2 minus cos 0. Cos pi by 2 is 0, so 0. So we are left with cos 0, which is 1. And our estimate, this is the answer we are getting from the integration. Our estimated area was 0.942, and I'd say yeah, they're pretty close. There's a difference of, so there's an error of 0.58. So this is the error. Now let us see how we got this error. Now let us go back to the original image. If we look closely over here, there is the blue shaded area is something which wasn't counted. It wasn't counted in our geometrical integration, like our estimation using the trapezoidal rule. This area and this area, it wasn't counted. So therefore, the blue area, is approximately equal to 0.058 units. So my bad here. Yeah, my bad. This is 0.058, the error. Now so and we are done. I'd say the trapezoidal rule, it gives us a pretty close estimate of the area. And one more thing is, as we increase the number of subdivisions, here we have taken 2 subdivisions, but as we keep increasing the number of subdivisions, the area which the trapezoidal rule gives us will keep going closer to the area which we get by integration. So if there are infinite subdivisions, that is basically what we do in integration, so it will be equal to the integration value. So yeah, and we are done.